Okay, let's talk about angles. I have a definition here listed for you. An angle is made up of two rays that share a common endpoint called a vertex, the angle created by rotating one ray away from a fixed ray. The fixed ray is also called the initial side, and of course the rotated ray where you end is called the terminal side. So we can have positive angles, negative angles, and you could have a zero measure. So let's look at a few examples. First of all, a zero measure would be if you start with an initial side and you don't move at all. That means you've gone nowhere. That would be 0 degrees. So let's look at a more traditional example for the second one. So if we start with our initial side and we rotate counterclockwise, so let's make a 45-degree angle. I'm rotating counterclockwise. This is a positive 45-degree angle. Our vertex is right at the point, and our initial side started the one that's going straight to the right, and then we ended with our terminal side. The next example is when we have a negative angle. So if we start with our initial side and we rotate clockwise, this makes us a 45-degree angle, but it's negative because of the direction. Okay, let's talk about different ways to measure angles. So we have two different ways, one with degrees and one with radians. Let's talk about them both. So if we look at a circle and we talk about angles, in degrees, if we were to go half of the circle, well, of course, if we start at 0, we have 0 degrees right there. Okay, if we were to go half of the circle, if we went half like this, that is 180 degrees. And of course, if you continued on and went the full circle, that's a whole 360 degrees. So if we talk about radians, let's say we start at 0 again. If we go half of the circle over here to 180 degrees, that's the same thing as pi. And then if we continue the circle all the way around, 360 degrees is the same thing as 2 pi. So when we talk about radians, radians usually has pi in the angle. So remember, half a circle is pi. The whole circle is 2 pi. So each rotation that you make around a complete circle, you're going a distance of 2 pi. So if you look at the top, I have 360 degrees is the same thing as 2 pi. 180 degrees is the same thing as pi. And then from doing a little bit of algebra to these two small equations, we get 1 degree is pi over 80 and 1 radian is 180 over pi degrees. We're going to use these in the next slide to help us convert from degrees to radians and radians to degrees. So as I said from the previous slide, if I were to give you an angle that was degrees and I wanted to rewrite that in terms of radians, we need to convert. And right at the top, I've told you how you do it. So if I wanted to convert an angle when you have degrees and I want to write it as radians, we just multiply it by pi over 180 and simplify our answer. So let's look at these examples. First, we have a 10-degree angle. We want to write it in radian. Now remember, radian is the measure that has pi in it. You can always remember that. So if I want to convert, I'm just going to multiply by pi over 180. Remember, 180 represents degrees. This is all with conversions. Our whole goal is to get rid of the degrees, so we are left with radians. So let's see. Try to write this small, but pi is radians. Okay, so when we multiply these, if you notice, we have 10, and divided by 180, we can cross out a 10, and that leaves us 18. The degrees crossed out too, so we are left with pi over 18. And then as far as our labeling, since the degrees crossed out, we're left with radians. So 10 degrees is the same thing as pi over 18 radians. That's how you convert. So let's look at negative 150. If we have a negative 150 degrees, we want to convert to radians. We multiply by pi over 180. Right? Just try to remember. A lot of times it's easy to get confused on do I multiply by pi over 180 or 180 over pi. Just remember our goal is we want our answer to be in radians. So when we multiply it out, we want to cross out the degrees. The degrees need to disappear. So if you notice, we have a degree in the bottom and the top. Those will end up canceling. That leaves us radian. So if you look at this, with 150 and 180, you can cancel out. Let's see, 30. I'm sorry, you can cancel out a 30. So if you take out a 30, that leaves you a 5. If you take out a 30 here, that leaves you a 6. 6. All right, and we have the negative, so we don't want to forget the negative. So that ends up giving us negative 5 pi over 6. And that's radians. All right. Okay. Now let's look at the next example. We're going to go backwards. If I give you radians and I want to go back to degrees, it's just the reverse. You multiply by 180 over pi. So to convert pi over 4, we're going to multiply by 180 over pi. Now think about it. We're converting again. Our goal is we want our degrees to be in our answer. So if you notice, the pi and the pi, those are radians. Those need to cancel out. Our answer in degrees will not contain any kind of pi. So those canceled out. And then 4 and 180, you can actually simplify that too. If you take out a 4, you get 1. If you take out a 4 of 180, you get 45. Right? So we are left with 1 times 45 and 1 times 1. So this is basically a 45-degree angle. And let's look at number 4. Negative 13 pi over 18. Once again, we're converting to degrees. Another way to remember it too is which way to multiply. Is it 180 over pi or pi over 180? The one that's on the top, which in this case is my 180, it's degrees. That's what I'm converting to. So if you know I need to write the answer in degrees, you put the degrees on the top. And like I said, the pi's should cross out. Right? Canceling here, 18 can cross out with 180 and leave 10. So we have, let's see, negative 13 times 10, negative 130. Right? And on the bottom, we're left with 1, so our answer is negative 130 degrees.